Hello guys and welcome to my channel. This is my first video on it and I want to present you some of the most viral and challenging math problems between 5th and 8th grades, which makes you feel great after you figured it out. So let's get started. By the way, this is the first problem from this channel. We have to show that exists 20 prime numbers different between them such that the sum of their squares is divisible by 3. Okay. A very important note is that 6k plus 1 and 6k plus 5 are the only expressions which approximately cover the whole set of the prime numbers greater than 3. Pay attention. Why? Because if we give values, natural values of k, we'll have for k equals 0. We have here 1 and here we have 5. For k equals 1. Here we have 7. We have 11. We have prime numbers. Prime numbers without 1. K equals 2. We have here 13. There we have 17. But for k equals 4. What about it? Let's say 4 times 6 is 24 plus 1 is 25. Oopsie, this is not prime. And there we have 29. Okay, we also know that 25 is 5 squared. But I promised to you that these are single-two forms that covers approximately the whole set of the prime numbers. Yes, I said approximately, not the whole, because 25 is a composite number. With this observation, we can write our problem very good. How? I wanted to do this observation to show you guys that these two expressions are not the perfect expression. Approximately. Remember that. Now we have with this expression to square them because 6k plus 1 in general is a prime number and there's also a prime number. We want to square them because we have to show that the sum of their squares is divisible by 3. So in the left side we have 36k squared plus 12k plus 1. Now we observe that this sum is divisible by 3 without 1. 1 is not divisible by 3. So we can factor this 3 out. So we have 12k squared plus 4k, close the bracket, plus 1. This sum, we'll know this with p, where p is obviously a natural number. We have, so 3p plus 1. Very important. So we'll note here 6k plus 1 squared is equal to 3p plus 1. Okay. After this, we have to do the same thing with this form by the same way. We have 6k plus 5 squared is equal to 36k squared plus 60k plus 25. which is equal to. Here I want to pay some attention on this 25 because we have a special number. Continue writing 36k squared plus 60k, but here we stop because we want to do plus 24 plus 1, which is the same with 25, equal to. But we see that this sum of three terms is also divisible by 3 because we have 36, 60 and 24, and we can factor this easily out and we remain with 12k squared plus 20k plus 8 plus 1. This sum of three terms will note this with, I don't know, b, where b is also a natural number like p and k. Is equal to 3b plus 1. We also find it a new important form of a square prime number. After we did this, now we have to delete this progress. Okay. And now we'll do just a little observation that I don't delete this. Okay. Now, what I have to do with this? I can see that 3p plus 1 is equivalent with 3b plus 1. In the other words, if we note this f of p equals 2 and f of b equals 2, we'll say that these functions are equal by drawing a graph. Very simple. Yes? Okay, but we are not interested about this. We did just an observation. Because we need this observation next. Because we will take (2020) prime numbers, but squared. How? Look. Let's say that we have the first squared prime number, 3a1 plus 1, is already a squared number because we have to substitute the letters p or b or a1 or I don't know what letter you want, plus the second prime squared number, 3a2 plus 1 plus dot 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 plus 3a2019 plus 1 plus another squared prime number 3 to the 2, which is equal to s. Okay, the sum. So what we have to do from here is very easy to see. Next, that here we'll have some common factors. out these brackets because we don't need it, and write like 381 plus 382, the bracket doesn't matter, plus dot dot plus 38 2019 plus what we have 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 by 29 times is equal to 2019 plus 3 squared 9 is equal to s. So we have here 2019 square prime numbers and the other squared prime number 3 to the second power. These forms are already squared because we proved previous. From here we can factor this 3 out and say a1 plus a2 plus dot 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 plus a2019 plus here we have 2028 which is equal to s. Okay, this whole factor, whole term, not factor, is a multiple of 3 because here we have the 3 and this 2028 also is divisible by 3 because 2 plus 2, which is 4 plus 8, 12, the sum, the digits, is divisible by 3. But what the theorem says, that a sum has the terms divisible by any number, in our case is 3, we have clearly that this sum is divisible also by 3. So that's the proof. Very nice. Thanks for watching my channel and hope you enjoyed this video. Please share this video to your friends to see the solution.